If you store your data warehouse project in a code repository, great job. This method, called infrastructure as code, has several benefits. It makes it easier to deploy your project to any server, whether it's old or new, and whether it's on-premises or in the cloud. It also lets different people work on the project together. But here is a catch. When more people work on the project, managing the code becomes tricky. A small mistake can mess up the whole data warehouse, and sometimes it's hard to spot these mistakes with the naked eye. So what's the solution? Well, it's DataOps, or to automate the process. With automation, we can set up a system that automatically builds and deploys your project to a test environment. It also runs your ETL tasks to make sure the new changes don't cause the problems. Tools like GitHub Actions and Azure pipelines can help with this. They use a compute, like a virtual machine, which can access a SQL server. This VM automatically does the deployment, runs ETL, and indicate whether the deployment is successful or not. In summary, CICD practices, short for Continuous Integration, Continuous Deployment, help your team work faster and gives assurance that the new lines of code don't break the system. Now we'll dive into the GitHub Actions for automation, assuming you are working with SSDT or SQL database projects and deploying to a on-premises SQL server. First off, think of your project as a piece of software. When you build this project, it produces something called a DACPAC, which stands for Data Tier Application Package. This DACPAC is a bundled version of your project, containing everything needed to set up your data structures on a server. Deploying this DACPAC manually, you would see a script. This script is what we're going to use to automate the process. But let's keep it in mind, we'll revisit it when we dive into setting up a YAML file. Now for automation, we need to set up the right environment. We create a Windows virtual machine on premises. This VM has access to our SQL server and has some software installed like .NET SDK, VS Code, SQL package, and the GitHub Runner package. Once set up, the GitHub Runner should show up as active if everything is installed correctly. Next up, we need a plan for the automation, which we write into the YAML file. This type of files are used to create configurations that are easy for humans to read and write. Besides GitHub Actions, YAML is also used in other software tools for configuration, like Docker Compose, Kubernetes, and many continuous integration tools. In our case, though, the YAML file will tell the GitHub Runner exactly what jobs and steps to take to automate our data warehouse deployments. As we set out to write our deployment steps in the YAML file, we come across a security challenge. Some information, like the SQL server name, may be sensitive to openly include, but we have no security concerns over the database names. Here is where the GitHub environments, along with its secrets and variables, come into play. Secrets in GitHub are always hidden, keeping sensitive details safe, whereas variables are visible and can be used for non-sensitive configuration. In our YAML file, we outline the process that goes like this. Define the environment. This sets the stage for where the automation will run. Download the repo to the VM. This brings our project code into the virtual machine. Build the solution. Here we compile our code, turn it into a DACPAC. Upload the artifacts. This way we can use these DACPACs further down the pipeline. Download artifacts to the VM and deploy. We use our variables here to deploy databases correctly, keeping sensitive information secure. And finally, clean up. After deployment, we remove any files from the VM to keep it clean. Also note that we have specified a trigger. We set this workflow to run whenever someone submits a pull request. This automatic checks ensures every contribution can be deployed and works as expected. If the deployment succeeds, we see a green tick, confirming everything is in order. If something goes wrong, a red cross appears, and we can look into the details to find out what happened. But that's just one way to use this workflow. We can also adapt it for pre-release testing, deploying to production, and even attaching the DACPACs to a release document. This flexibility is a powerful tool in our automation arsenal. I hope this demo gives you a more clear picture of how to secure and automate your data warehouse deployments. Good luck with further automation. If you are intrigued by automation and want to master building a data warehouse from scratch, I've got a course for you. We're going to dive deep into some interesting data, develop a comprehensive data model, and set up a solution that we'll maintain in a cloud repository. You'll see the automation in action and get to play with some fun analytics. If this sounds like your next learning adventure, click the link in the description below to sign up. By subscribing early, you'll be notified when the course goes live and enjoy a special discount as a thank you for joining now. I'll see you there.